ideal gas equation. The combination of Boyle's law, Charles' law and Avogadro law leads to an equation which gives the combined effect of change of temperature and pressure on the volume of a gas. Okay, so according to Boyle's law, V is inversely proportional to P at constant temperature and N. Okay. Now Charles' law. Charles' law. V is proportional to T at constant pressure and number of moles. Okay, N. Then Avogadro law. V is proportional to N. N is the number of moles. V volume at constant temperature and pressure. These are the three laws. All these three laws on combining, we will get V is proportional to 1 by P, which is proportional to T, which is proportional to N. Or we can write PV is proportional to NT, or PV is equal to nRT. T, where R is a constant which is called as universal gas constant, and this equation is known as ideal gas equation. Now this ideal gas equation contains four variables, that is pressure, volume, the number of moles and T are the four variables present in this equation, and this equation describes the state of a gas, okay, state of any gas. So it is also called as equation of state. Okay, so this equation is also called as equation of state. Okay. If temperature, volume and pressure of the fixed mass of a gas T1, P1 and V1 vary from this T1, P1 and V1 to T2, P2 and V2. So these are the initial temperature, pressure and volume of a fixed amount of gas, and it varies to T2, P2 and V2. Now we know, according to ideal gas equation, P1 V1 by T1 is equal to nR. Similarly, P2 V2 by T2 is equal to nR. Okay, so from this we can write P1 V1 by T1 will be equal to P2 V2 by T2. This is another relation, and this equation is known as combined gas law. Other form of ideal gas equation, and we know, according to ideal gas equation, PV is equal to nRT. Okay, and also PV is equal to N is given mass by molar mass. So we can substitute here RT. Okay, now PV by RT, P by RT is equal to M by M into, this is molar mass and given mass, into volume, and we know density is equal to mass by volume. So P by RT equal D by M, or M will be equal to dRT by P. So from this is another relation. Using this relation we can find the molar mass of the gas. If D density, R then universal gas constant, T temperature and pressure are known, we can find the molar mass of the substance of the gas. Okay.